We'll start by talking about space and how we benefit from space systems. How do you typically use space each day? You might say you don't know, you don't care, or you may recognize that space systems provide our TV, radio, weather forecasts, pictures of faraway locations, a navigation system used in cars, boats, and airplanes, and even defense of our country. The average person in the U.S. uses 9 space assets every day, often without recognizing it. By knowing some of the everyday uses of space, we begin to understand what makes space systems important to us. After studying this chapter, you'll see the unique advantages of space and how you, your friends, and your family benefit. Soon, you'll know what elements make space missions and systems successful. In this first chapter of aerospace science, the exploration of space, we'll understand why we go into space, how we create successful space systems, and how we get to space. After all, space is just an hour's drive straight up, so why is it important? In this lesson, we'll discuss why space, and know the significance of space in the lives of people around the world. After that, we'll look at the specifics of space missions and the key building blocks for space systems. Okay, let's go to work. You should know 5 key advantages of space: global perspective, clear view of the heavens, free fall environment, abundant resources, and the final frontier. In the next few minutes, we'll discuss good examples of each one. Can you think of examples too? Historically, adventurers like you, scientists, and the military have sought high ground. Our ancestors climbed the nearest hill and mountains to see where they were and gained the benefit of seeing the big picture. The military used balloons and later airships to improve their view of the landscape and their enemies. Today, we use airplanes, high-altitude aircraft, and yes, spacecraft to get a view of Earth. In this figure, you can see how spacecraft see the Earth. As the spacecraft travels around the Earth, eventually they can see most of the planet. This allows us to do amazing things. If we put a camera on the spacecraft, we can take pictures of and literally listen to the Earth. We can watch what's happening to the Earth and what people are doing. We can monitor the weather and track activities in nature and, hopefully, prepare for disasters like hurricanes, tornadoes, floods, and volcanic eruptions. Spacecraft also help us communicate globally around the world. We're able to talk to others anywhere on Earth if they have the right telephone or receiving equipment. Radio and TV use spacecraft to transmit worldwide. Now, let's point the spacecraft away from Earth and view the heavens. Why are spacecraft so good at looking at stars, planets, far into our solar system, and universe? Well, a spacecraft actually flies above most of the atmosphere. The atmosphere clouds our view of space, so being above the atmosphere lets us see much farther. Also, because of wind gusts, the atmosphere causes the stars to twinkle, officially called scintillation. Here, we can see the Hubble Space Telescope, which has taken awesome pictures of faraway galaxies. Other spacecraft, like the Gamma Ray Observatory and the Chandra X-ray Observatory, offer improved views that increase scientific discovery about our galaxy and those beyond. This photo, one of thousands taken by the Hubble Space Telescope, shows a star-forming region that is billions of miles from Earth. We believe the Sun was formed in a similar way. By using the Hubble Space Telescope and other satellites like it, scientists are learning more about Earth and how the solar system and universe were formed. That's what space looks like, but how does it feel to be in space? If you're sitting in a chair, what's holding you in it? The answer is gravity. Earth's gravity is pulling you down into the chair, and the chair is pushing up on you. You feel a contact force from the chair. But if you were in a spacecraft, you'd be falling around Earth with the spacecraft. If you were to try to sit in a chair while you, the chair, and the spacecraft were falling around the Earth, you wouldn't feel the chair pushing up on you like you do here on Earth. There's no contact force to deal with. In orbit around Earth, a spacecraft and everything else is in free fall. Free fall lets astronauts float around in their spacecraft with ease, as shown by these smiling astronauts on the shuttle mission STS-95. So, astronauts, working with scientists, can study how gravity affects chemistry and biology, and to develop and mix advanced materials like beneficial drugs and new metal alloys. These materials mix or join in space because no contact forces try to push against their surfaces. Now, let's talk about some of the resources available in space. Space is full of useful resources. In fact, we use solar energy from our sun, to bring power and heat to many places on Earth. Planets, asteroids, comets, and even our own moon can offer us incredible resources. Take a look at this photo of Venus from the Magellan spacecraft. Magellan's instrument saw through the dense clouds of Venus to reveal a landscape full of minerals. Because Venus is far away, these resources are hard to get. But other bodies, like our moon, have great promise. Collecting energy from the sun doesn't depend on time of day or weather conditions. Astronauts can mine minerals like aluminum and gases like oxygen from the moon, asteroid, or planets. Space missions can use them to propel rockets, support life, and create living quarters. Do you like to hike and explore new places around your home? Our ancestors chose to explore unknown areas of the Earth and discovered America. People have an overwhelming urge to explore, and space exploration offers us a final frontier. That's what the old Star Trek TV series and movies called space, and it's true, because we can go boldly where no one has gone before, and we do. Most space exploration is done by robotic spacecraft that people build and operate. Sometimes people explore using technology to help them survive and discover unknown worlds. These events stimulate new technologies and help us in everyday life. So, how do we actually use space? More than half of the 550 or so operational spacecraft flying in 2007 were devoted to providing communications, including telephone service, television, radio, and the internet. Other spacecraft observed Earth and other heavenly bodies, called remote sensing, or helped cars, trains, planes, and aircraft get where they were going. Still others supported science and exploration missions. First, let's look at space-based communications. In your car, what happens when you tune in your favorite radio station and drive to another state? At some point, the radio station begins to fade and eventually becomes unavailable. That's because as you distance yourself from the radio station, two things happen. The power received from the radio signal decreases, and Earth's surface falls off about 15 feet for every 5 miles you go away from the radio station. This second effect causes you to lose line of sight to the radio station. And if you can't see the station, usually it's hard to get the radio signal. But spacecraft have much better line of sight to huge regions of the Earth. In fact, it only takes 3 spacecraft in certain orbits to cover almost all the Earth for radio and TV coverage. So, space-based communications allow us to communicate with people all over the entire globe. As we just said, looking and listening from space are referred to as remote sensing. By combining the unique capabilities provided by being in orbit above the Earth with instruments that can look, listen, and gather information, we can do lots of things. We're able to see what's happening on the Earth regionally and globally. It's now possible to get detailed pictures of most locations on our planet. For example, we could get a picture of your school in good detail from space. And we might be able to count the numbers and identify the types of cars in the parking lot. It's also possible to determine the pollutants in an ocean, river, or large section of property here and on other planets, asteroids, and comets. Remote sensing information is very useful to civilian and military organizations. Now, let's look at one of the most useful, tracking and predicting the weather. We've all heard of and been touched by natural disasters like tornadoes, hurricanes, volcanic eruptions, and floodwaters. Sophisticated weather satellites help scientists monitor these weather patterns globally. By capturing satellite images of clouds and storms, we can provide early warning of disasters like hurricanes, similar to Hurricane Katrina. Have you ever been hiking or driving and been lost? Or have you wondered how to get to another location? Navigation answers the question, where am I? The U.S.'s global positioning system allows anyone with a GPS receiver to figure out where they are on land, on the sea, and in the air. Today, we combine location information from GPS with other information like city traffic patterns to figure out a path through a city that avoids heavy traffic and delays. Navigation is one of the most significant space assets available to us. Using space-based communications, remote sensing, and navigation, we can do great science and explore the universe and beyond. Would you rather explore a canyon or dangerous rocky cliff yourself, or send a remote-controlled robot? It depends, right? Let's assume you like adventure and have good common sense. If the effort wouldn't be dangerous or life-threatening, you may want to explore yourself. But exploring is likely to harm you. So a robot with a video camera would allow you to see everything, but stay safe. On the left, you can see the complete International Space Station, an orbiting laboratory for scientific investigation. You should visit NASA's website and see what's going on with the ISS. Often, we send robots out to do scientific research and explore planets, moons, asteroids, and comets before people go to them. For example, we have many images of the moon's front and back sides that help us figure out where we'd like to land when we travel there. Interplanetary probes like Mariner, Viking, Voyager 1 and 2, Magellan, and the Mars Pathfinder have collected information about the planet's chemical makeup, orbits, and moons. Planetary probe missions have caught the public's imagination by producing spectacular images from the surface of Mars and the rings of Saturn. Answer the following questions and get off to a good start by making sure you understand all the material in this section. This is a silent clip that begins with a spacecraft near Mars. You'll see the spacecraft taking pictures while flying by Mars. The spacecraft sends the images to Earth by pointing its antenna toward Earth. Then, the spacecraft uses the atmospheric drag around Mars to lower its orbit. Finally, it'll take some close-up pictures, enter Mars' atmosphere, and burn up. This is a great example that combines robotic exploration, remote sensing, and communications. We've learned space is a unique place, even though it's actually only an hour's drive straight up. Once in space, we can clearly see Earth and the heavens, access the free-fall environment, and explore Earth, the solar system, the galaxy, and the entire universe. We've learned how to use space for communications, remote sensing, navigation, science, and exploration. In this section, we talked about the importance of space and how we use it. In our next section, we'll look at the building blocks of a space mission, which include the mission, spacecraft, trajectories and orbits, launch vehicles, systems that help operate a mission, managing and operating the mission, and how the overall structure, called the Space Mission Architecture, supports it.